I am looking at this. First of all, I'm looking at the internet and I typed in ozone layer because they say that planet Mars, because look at, there's the sun, Mercury, Venus, Earth, planet Earth, and then planet Mars. Okay, so they say that planet Mars is hotter than planet Earth. So I was thinking, how is the ISS like, how is the ISS not burning up? Because it's outside of the Earth's ozone layer. But according to this, there's different types of layers. Okay, which I never really thought of. So that's probably the reason why the astronauts are able to walk out of the ISS to do maintenance. Okay, they're able to go out and perform maintenance if required and stuff like that. So that's probably why they're not overheating, I'm assuming, because I heard that there's an ozone layer that protects planet Earth from the sun's heat. Oops. So I was just wondering if the ISS is out here in space somewhere and is not harmed by the sun's rays. I was wondering why and how that's possible. But there is a Wikipedia definition regarding the ISS. So I guess my question would be, how far is the ISS from Earth? Right here it says 254 miles or 400 kilometers. But over here is specifying km. So if we get 254 miles to km, it's actually 408.773. So that's 408.773 kilometers away. So going back to this, that would mean that it's in the thermosphere, and since it's near, almost near 500, that would mean that it's on the edge of, like, almost in between the thermosphere and the exosphere zone, just about, but still within the thermosphere. So in perspective, the ISS is between the exosphere and the mesosphere. Okay, so it's it's right here in between mesosphere and exosphere, right? But yet the ozone layer is over here. So I don't know how that works, but I'm sure there's a science to it, and maybe that's why they have this graph here. So I guess the next question could be, how can astronauts survive in the thermosphere when they perform maintenance to the ISS? Okay, so that's my question right here. How do astronauts pass through the thermosphere? No, that wasn't my question. Oh, okay, yeah. How can the ISS survive the thermosphere? Yeah, the thermosphere, okay? So, it says, while the temperature of the thermosphere can reach almost 2,000 degrees Celsius, 3,632 degrees Fahrenheit, there are not enough gas molecules to transfer the heat to materials, which is why astronauts and the space station do not melt. Okay, so I guess the same, I'm assuming the same will be true for the astronauts that go out to perform maintenance. There's just not enough gas molecules to transfer the heat to the materials, or through the materials, which will then cause the human body to at that temperature probably explode, I don't know, or liquidate. No, I think it would blow up, right? Like dropping it, it'll be like dropping a water drop on a hot stove. It would just turn to vapor. So, well, it says while the temperature of the thermosphere can reach almost 2,000 degrees Celsius, which is equivalent to 3,632 degrees Fahrenheit, there are not enough gas molecules to transfer the heat to materials, which is why astronauts are included, and the space station do not melt. Think about it, melt. Iron's melting point, 2,800 degrees Fahrenheit. So that's probably why. So it could be possible that the coolest point would be opposite of the sun's direction from Earth, right? And right when the sun is hitting planet Earth, midpoint, which is 12 p.m. and over here it would be 6 a.m. No, there's 24 hours in a day. So there's 12, 6, and then 6 and also represents 18, right? So it's either 6 on the clock, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 on the clock, perfect circle. So obviously the hottest point will be 12 p.m. and I'm assuming the coldest would be 6 p.m. or 18 18 which will be I think nighttime hours. So it's kind of like like the way I can see it is like a lunar eclipse. Eclipse. Like this. This is a perfect graph. This is what I'm trying to say here. So, if you guys think about it, the sun right here, it would be the hottest, right? This would be like 12 p.m. and this would be 6. No, that would be impossible, right? So yeah, this would be 18 on the clock. So that would mean that this would be probably the safest time to send out a ship or something. Especially if the sun could possibly harm it. But I heard that there's satellites and stuff out there, like in outer space. How do satellites survive the How do satellites survive the sun's heat rays without the protection of planet Earth's ozone layer? Okay, do satellites go through the ozone layer? The satellites are mostly made of aluminum and contain numerous electronic parts, batteries, carbon fiber, epoxies, and materials including titanium, magnesium, lithium, nickel, and cobalt. Materials that may contribute to ozone depletion as they continuously disintegrate in space and descend into the stratosphere. So, where is this stratosphere? Stratosphere. That's only 50 km. Stratosphere right here. Let me see here. materials that may contribute to ozone depletion as they continuously disintegrate in space and descend into the stratosphere. Okay. How far is one particular satellite from planet Earth? How far up are satellites in miles? What is the furthest point of a satellite to Earth? How many times does the satellite orbit the Earth in 24 hours? How fast do satellites travel? Can we see satellite from Earth with naked eye? Well, now I'm confused because they said that they send rovers to Mars, to planet Mars, and I heard that there's satellites deep into space, looking at like other planets and stuff like that. So I don't really know how that works. Like, okay, let's just look at planets, Mars, satellites. That were sent from planet Earth. Okay, right here. Okay, so we have these satellites that were sent to planet Mars. So how did they exit without getting destroyed? You know, is it something, did they take these precautionary measures? I mean, is a launch, a rocket launch, timed just perfectly? Maybe to avoid the sun, you know, so it could take off to planet Mars. That's what I don't really understand. Because there is the rovers out there on planet Mars, and there's a bunch of discussion regarding these rovers. Perseverance is the one that I kind of am familiar with. So I don't know. I don't really know know how they did it. Is my question, and how they managed to do that without the sun damaging the equipment, the sun's rays. Oh, but I do know, now that I think about it, that they are encapsulated. So I think that, well, obviously the rovers that are sent, what's up, Carlos? That are sent to planet Mars. The rovers that are sent to planet Mars are protected by the capsulators. So that would be, no, not this thing right here. This is the capsulator that can withstand heat by a ton of degrees.
Are you down for some brew?
No, I haven't been drinking.
No?
No.
Alright.
You gonna go buy some?
I'm not submission.
Titi, where'd you go?
Where's he at?
In his room, probably. So, yeah, there's the heat shield, obviously, and then everything's inside of it. The rover down look camera. So the rover's in there. That decent stage down look cameras. Everything's protected. So that would mean that the satellites will also possibly be capsulated. To exit planet Earth's ozone layer without it getting harmed, you know, by the sun's rays. Oh yeah, and then like right here, like it says that that the thermosphere where the ISS is located, it says can reach almost 2,000 degrees Celsius, right? So that means that beyond that point, it's most likely possibly hotter than that. Let's look at how hot planet Mars gets. How hot does planet Mars get to? Well, we'll just say get. The Department of Mars can be as high as 70 degrees Fahrenheit, 20 degrees Celsius, or as low as about negative 225 degrees Fahrenheit negative 153 degrees Celsius, and because the atmosphere is so thin, heat from the sun easily escapes this planet. Oh, I get it now. It's like heating up water, and it'll easily get cooled down because the atmosphere around it is so cold. Like, tossing this hot water in a cold, kind of like frozen lake, but not entirely frozen, it will just lose its heat. So the atmosphere of Mars is so thin that heat easily escapes the planet. So I heard that planet Mars got like really hot, but it says the temperature on Mars can be as high as 70 degrees Fahrenheit, which is pretty cold still. That's like comfortable. That would be like comfortable weather, because most homes, I believe, get set to 72 degrees in Fahrenheit, and that's like comfortable. Obviously, over that, it would be too hot, I guess, and negative 225 degrees Fahrenheit. I don't know where on planet Earth does it reach negative 225 degrees Fahrenheit. Death Valley is known for having the highest air temperature on the planet, according to science.org. The Furnace Creek area in this part of the California desert reached a sweltering 134.1 degree Fahrenheit, or 56.7 degrees Celsius on July 10th, 1913. Sweltering. But that's not. Yeah, Fahrenheit. So it gets colder on Mars. But I guess, there's electricity, batteries that can most likely warm up the rovers. But right here it says that the heat from the sun easily escapes this planet. So that would also mean artificial type of heating will escape as well, unless it's within a thermo or something like that. Protected heat, a protected heat source. So, yeah, I don't know. I don't know how they're planning on but I don't understand how they plan to colonize planet Mars. Because, water freezes at negative 30. Negative freezing point, negative 32. 32 Fahrenheit. Fresh water freezes at 32 degrees Fahrenheit, but seawater freezes at about 28.4 degrees Fahrenheit because of the salt in it. When seawater freezes, however, the ice contains very little salt because only the water part freezes. It can be melted down to use as drinking water. So that would mean that, overnight at these type of temperatures on planet Mars, that sounds deadly. I don't see how they're going to survive that. But I answered this type of research that I just did right now pretty much solved my question as far as why and how the ISS is not harmed by the Earth's, the solar system's heat from the sun, right? And it's partly because, I'm assuming because of the ozone layer. But, yeah, because they were talking about sending, spaceships and stuff like that to planet Mars. Yeah, humans to Mars. When will they send humans to Mars? The mission said to launch toward the end of 2004 will be the first crewed flight of the Orion spacecraft, the vessel that has been tapped to send humans to Mars. And there's even a Wikipedia definition regarding all of this, if you guys are interested. But that's pretty much all I want to share with all of you.
Rocky, you're not gonna play?
No, Tia.
Wow, your room looks nice.
Thank you.
And it smells good.
Does it?
Yeah.
Thanks.
Mijo, te voy a molestar de vuelta. Can you charge my phone?
You need me to charge your phone?
Yeah, because I came and picked up my mom and everybody and se me pendejo.
Let me see your phone.
It's the little big one.
Maybe this one? Oh yeah, it's charging.
¿Sabes qué? Le debería bajar la luz, ¿verdad?
No, it's
¿Voy
fine.
a cargar? No sé qué pagarlo porque se pone el pinche güey. You don't want to play?
No thanks.
¿Y ahora siempre jugabas?
I'm thinking about money, not playing. Real money.
Yeah, it's true.
Human mission to Mars. So, wow, this is so incredible. Just the fact that they were able to figure out how to send all this stuff out there on planet Mars is very fascinating. Anyways, I guess everything is just science. It comes down to science and very intelligent people who know what the heck they're doing. But I'm the one who is studying and trying to figure out what others have learned. What others have learned and applied, obviously. You know, because this is, this speaks for itself right here. These satellites that were sent from planet Earth to planet Mars, it speaks for itself. How smart these people are and intelligent. How intelligent they are to have figured out all of this complexity. So I really don't understand, though, how humans are going to survive that type of weather. But I always thought that planet Mars reached a higher temperature than 70 for some reason. the hottest it will get on planet Mars? Let me see. I'm going to search that over here. So, like it says 70 degrees Fahrenheit. So, I'm going to I don't know. But maybe the temperature drops. The furthest any particular object is from the sun, so it says on average the temperature on Mars is about 80 degrees Fahrenheit. So that's not the issue. The issue is not them roasting to death. The issue is them freezing to death. I get it now. Okay, so now my only other question will be, how the heck did they manage to get these satellites how do we get these satellites to to exit, to pass the deadly sun's rays? Okay, let me type in another question. How hot or what is the hottest possible point outside of planet Earth? I'm not really finding the results that I want.
That's sticky. Well, you can find them.
Wait a minute.
Oh, here.
So I remember reading something about the thermosphere
Yeah, they always do that.
and temperatures ranging from or around 2,000 degrees Fahrenheit. So that means that if we look at the next layer outside of the thermosphere, which is the exosphere, let's study the temperature. The temperature of the exosphere is technically around 987 degrees Celsius. So I need this converted to Fahrenheit, which is 1,808.6. Alright, so why, my question is how is this stuff not harmed, and how is it protected from the sun's heat? But we did discover, well, I did, and if you guys are new, we discovered that the gases don't permit or don't allow the heat to get transferred or something like that into the materials, which I said earlier, but I didn't say it. It was something I discovered through the internet. Okay, so I would have to just reference back to that, because obviously I'm not writing notes down. But there you guys have it. So my next question is, how do man-made objects survive past the exosphere. How long do man-made objects last in space? Can humans survive in the exosphere? Question mark. How do rockets get past Earth's atmosphere? How does the exosphere protect life on Earth? What objects can be found in the exosphere? I think this one. How can humans survive in the exosphere? I think would be one worth looking into. It says no human can survive this.
Frankie.
Yes.
Come in, Frankie.
Yes.
Okay, hijo.
Open.
Death is likely in less than 2 minutes. Lynn Hart said, "You're welcome." According to NASA's bioastronomics data book, the vacuum of space would also pull air out of your lungs, causing you to suffocate within minutes. This was probably published or updated November 13th, 2021. Well, obviously, but what about in a fucking spaceship? Like, I don't know how that's possible. I don't know how that's possible. So let's look back at the lunar eclipse to pull up this chart. So the exosphere reaches temperatures of 18,000 degrees approximately Fahrenheit. Okay? So that means that these astronauts or astronomers, people who study the planets and all of this stuff, probably send out the rockets at the coolest point, which is the opposite side of where the sun is the hottest, the midpoint on planet Earth. So once they calculate that, then that's probably when they send these ships out. So most likely at nighttime, right? Unless the rocket goes up and loops around and then eventually takes off, and then well, that one was good. And then so it takes off, and then it'll land on or hover around, hang out around the ozone layer or whatever of Mars. Does planet Mars have a ozone, or I would have to say an ozone layer? On Mars, which has no ozone layer to protect it, solar UV rays strafe the surface with deadly effect, leaving the apparently lifeless planet without the simplest of organic molecules in the upper millimeters of exposed Martian soil. So why is there no ozone on Mars? Ozone layer. The thin ozone layer on Mars is produced when the solar ultraviolet light breaks the CO2 molecules that compose 95% of its atmosphere. Conversely, ozone on Mars is readily destroyed by the hydrogen species. So they found life on planet Mars. Hydrogen species released by the water vapor. So yes, there is water vapor on planet Mars. This was updated April 8th, 2021, and they did find water on planet Mars, in case any of you were wondering, or if you're not up to date. Okay, let's look at the sunscreen lotion, SPF definition or meaning. So it stands for SPF, stands for sun protection factor. Before you buy sunscreen, it's important to understand what sun protective factor or SPF means. That's the number you see on the bottle when you're picking out your sun's safety products. A sunscreen's SPF is a measure of how well it protects you from getting a sunburn. Okay, let's look at this. What is better to use, SPF 30 or 50? Okay, let's simplify this. A sunscreen with SPF 30 will protect you from around 96.7% of UVB rays, whereas an SPF of 50 means protection from about 98% of UVB rays. Anything beyond SPF 50 makes very little difference in terms of risk of sun damage, and no sunscreens offer 100% protection from UVB rays. So that means if these Martians are, Martian astronauts that go to Mars, which will be considered Martians, Martian voyagers. Well, anyways, that means that they would have to use something that has an SPF, graded type of sunscreen that has a higher number, probably, right? Especially if the sun touches their skin or something, because it will probably burn, because it doesn't have. We just discovered that planet Mars doesn't have an ozone layer. And it gets 80 degrees. Planet Mars gets around 80 degrees. Mars is very cold. The average temperature on Mars is minus 80 degrees Fahrenheit. Way below freezing. Its surface is rocky with canyons, volcanoes, dry lake beds, and craters all over it. Red dust covers most of its surface. Wait, what is the hottest it can get on Mars? So right here it's saying 68 Fahrenheit. Oh, this is the average temperature. The average temperature on planet Mars is minus 80 degrees Fahrenheit. Okay. It says Mars is actually pretty cold. In orbit, Mars is about 50 million miles further away from the sun than Earth. That means it gets a lot less light and heat to keep it warm. Mars also has a hard time holding on to the heat it does get. Also, it probably won't feel that hot, even though it gets to be like 80 degrees. So it will be like a 80 degrees type of day in California, but on a windy day, and possibly, like instead of hanging out in direct sunlight, it'll be more like hanging out underneath the shade of trees. Which I know from experience that if it's 80 degrees or even hotter outside, I would personally prefer to be in the shade, and I would prefer for the outside to be very windy so that my body can cool down and stuff like that. Alright. Let me see here. Yeah, I still don't understand. I still don't understand how these objects go without melting, because it said something about melting. Remember that earlier? We were studying the thermosphere, and I asked a question, and it said that the ISS and humans, the ISS and humans don't melt in the thermosphere because something about the gases don't penetrate the materials or something like that. Yeah, right here. There are not enough gas molecules to transfer the heat to materials. To the materials. In this case, the way I'm phrasing it, okay? Because I'm just reading a sentence here. That makes sense, by the way. So anyways, 3,600 degrees Fahrenheit. So I'm assuming that, the further satellites and like other objects, if they go outside of this ozone layer thing, these layers, the same will probably be true, I'm assuming, because it's colder at the same time. Because Earth, space is cold, right? So the same will be true that there are not enough gas molecules to transfer the heat to the materials. Heat transfer. So obviously, for humans, the sun's rays can be deadly because they have no protection other than the ozone layer. But since humans are within a spaceship that is protected, that protects them from the sun's heat rays, they can possibly go out here without the ship melting. Because right here it says let me read this whole thing again. Why does the ISS not melt in the thermosphere? And that's where it's at. It's at approximately 500 km from the ground, or from the sea level. Okay? So it says, while the temperature of the thermosphere can reach almost 2,000 degrees Celsius, which is equivalent to 3,632 degrees Fahrenheit, there are not enough gas molecules to transfer the heat to materials, which is why astronauts and the space station do not melt. This was edited or revised or whatever on June 1st, 2018. So I guess this answers my question. I will just say that satellites and spaceships that will be getting sent to planet Mars will not melt, even if it exits the protection of the ozone layer, because the spaceship acts like its own ozone layer for people within it, that are within it. Or for humans who are within it, any spaceship. What is the furthest man-made satellite in our solar system or galaxy? I guess both would be good. No spacecraft has gone further than NASA's Voyager 1, launched in 1977 to fly by Jupiter and Saturn. Voyager 1 crossed into interstellar space in August 2012 and continues to collect data. Voyager 1 and its sister ship Voyager 2 have been flying longer than any other spacecraft in history. And let's look at some images regarding this. So here's a graph or like an illustration for us to look at. Oh, and it's in Wikipedia, which is super cool. I love Wikipedia. So we can see right here Saturn. I'm assuming this will be like Pluto. And then it's referring to some type of solar wind, which I never heard of. But either way, we can see Voyager 1, Voyager 2, and then there is another one over here. It looks like the name is Pioneer 11 over here, and then there's Pioneer 10. And then this circle thing is classified as termination shock. So the termination shock definition. Let's look at that. Termination shock: the place where the speed of solar wind becomes slower than the speed of sound is called the termination shock. So there's actually some images regarding this. Whoa, these people are super educated. Look at this. This is called the heliosphere. Then the termination shock. Then the helopause, the bow shock, and then there's an interstellar medium. So those are just different layers outside of our solar system or galaxy. Or is it the same? Solar system. Says Voyager 1 has reached a distance of 23.381 billion kilometers km, which is equivalent to 14.528 billion miles. And I don't know what this is here. Something, it says 156.29 AU. Voyager 1 has reached a distance of blah 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 from Earth and 23.483 billion km from the sun. So that's how far that thing is. And I believe that obviously with technology, eventually we will be able to travel that distance in no time. Half the time. 80% of the time. And eventually time travel. Because AI technology is nothing to mess with. AI technology is smarter than any human being. And it will be able to figure all this stuff out without any human intervention. Especially now that it's self-learning. I mean, these astronauts are lucky. They're not melting and exploding out there. However, I'm done with my little research stuff here. I wonder how cold it is though. Over here where the Voyager 1 is and all these other satellites, man-made satellites. I wonder how cold it is. But that's a whole different video. And I guess you guys can always do your own research regarding that. But I'm out of here. Peace out, everyone. God bless.